In this video, I'd like to talk about determining congruent triangles. And when determining congruence between two different triangles, there are several different rules that we can use. We can use side, side, side. We can use side, angle, side. There's also angle, side, angle. And then we have the angle, angle, side theorem. And after this, we also have hypotenuse leg, which is a special case of the side-side angle relationship. Now, side-side angle is only true when this angle is 90 degrees. Otherwise, this leads us to two different triangles. Or in other words, if you have triangles where they share two sets of equal sides and an angle that's not between the two equal sides, then there are two possible triangles that can be formed out of this relationship. But when the angle is 90 degrees, then you have a right triangle and it works as a congruence relationship. So this does not give us enough information, but when it's 90 degrees, it does give us enough. And the other case we have is the angle, angle, angle relationship, where all of the angles in a triangle match up. And while it is true that congruent triangles have all equal angles, it's also possible that you have two triangles where all the angles are equal and one is much larger than the other. It's essentially a scaled version of the smaller triangle. So when you have this angle, angle, angle relationship, the triangles are similar, but not necessarily congruent. They can be congruent, but in most cases, they are just similar. They're the same shape, but different sizes. So it's these five that we're concerned with. And if we end up with either of these two other cases, we don't have enough information. Now, looking at this problem here, we have these two triangles, and what we can see is that they share one set of equal angles here. They share an equal side length, and it looks like they share another set of equal angles. And what you can notice is that the side is in between the two sets of equal angles. And this is what we call angle, side, angle. So we can use this congruence postulate or congruence rule to determine that these two triangles are congruent to each other. They are the same size and the same shape. So in this case, they are congruent. And let's look at one more example here. And for this problem, we again have two different triangles. And what you can see is that they share this side length where it's length 6. They share a side length of length 5, and they share a side length of length 9. So between the two triangles, they share three sets of equal sides, and this is the side, side, side congruence rule, which means that yes, these two triangles are congruent. And remember, when triangles are congruent, they also have corresponding angles being equal to each other. So the angle, let's say between 9 and 5, these two side lengths, would be equal in the other triangle. So the one between, again, 9 and 5. Likewise, the one between the side length of length 5 and the side length of length 6 would be equal in both triangles. And then the third angle here will be equal to the third angle here. And this we can deduce from the fact that they have all equal sides. So we have the side, side, side congruence relationship. And since they are congruent, they also have correspondingly equal angles.